Alright guys, Coach Goo, Coach T back at it again with another fun-filled, action-packed, flipped geometry video. So today, if you realized last time, you were like, man, I had to use my brain. If you had a headache after last time, well, get your Tylenol ready today because we're going over related conditionals, okay? So we're gonna have to use our brains and really kind of scramble around for these ones. So here we go. Let's get it started. First, we've got an inverse. Remember, yesterday we were just messing with the conditional statements, the if, then statements, the P, then Q statements. If P, then Q. Today, we're gonna mix it up a bit. We're gonna get a little scrambled up in here. So first we got the inverse, and the inverse is formed by vocabulary word negating. Negating. Do you know what negate means? It means to make null. Pretty much you're putting the negative version of it, okay? So we're formed by negating the hypothesis and the conclusion. Remember, hypothesis is P and conclusion is Q. So the symbolic form for the negation of both would be squiggly line P, arrow, then squiggly line Q, okay? And that means if not P, then not Q. All right, let's go to the next one. We're gonna do some examples later on, but first, let's just get these definitions down, okay? Converse. And that's not like the shoes. That's not like my fly white shoes that I have that I don't wear to school that much because it rains a lot. And that's formed by switching the hypothesis and the conclusion. So if the hypothesis is P and the conclusion is Q normally, and we switch it, then what's our symbol going to be? It's going to be Q, then P. So if Q, then P. And last one, we've got the contrapositive, and that is formed by negating and switching the hypothesis and conclusion. So look, normally you start with P then Q, right? We are going to negate, so we're going to put negative P and then negative Q, and then we're going to switch it so it's negative Q is to negative P, and that is the contrapositive. So oh my gosh, what is that? If not Q, then not P. All right. Now we're gonna do some examples, and hopefully you'll understand, grasp this, wrap your head around this a little. I know at first it seems a little confusing, but as we do more and more examples, then hopefully your head wraps around and becomes a little easier. So let's look at the directions. We're gonna write the inverse, converse, and contrapositive of these following conditional statements. Then we're going to determine the truth value. That means, is it true or is it false? It just sounds a little fancier, the truth value. If false, provide a counter example. That's what we did yesterday. So I'm going to scroll it down. So this page is going to delete. Scroll down. So let's do number 1 first. Whoa. Here we go. So the original statement is, if it is Saturday, then there is no school. So let's label the P and then Q to help us out a little bit. So if P is it is Saturday, and the Q, the conclusion, is there is no school. So if it is Saturday, then there is no school. That's P, then Q. So the inverse, what is the inverse? If you look up at your notes, it's formed by negating the hypothesis and conclusion. It's not, if not P, then not Q. So P is if it is Saturday, so not P would be if it is not Saturday. Okay, and then originally we had then there is no school. So if we take the negation of there is no school, then that would be then there is school. See, originally we had the no right here, but we crossed that out. So now there is school because we're taking the negation. All right, so that is the inverse. Now, is this true? Now think about it. Think about it. If it is not Saturday, then there is school. Is that always true? No, because what about Sunday? Do you go to school on Sunday? Maybe you do, but there's technically no school on Sunday. So false and Sunday is our counter example. Now let's do the converse. Look up at your notes. How do we get the converse? We get it by switching the hypothesis and conclusion. So our symbol would be if Q, and I'm just gonna use some colors, then P. So where is Q? Q is there is no school. So if there is no school, then where's P? There it is. It is Saturday. Then it is Saturday. So as you can see, we're just making new statements. We're making an inverse statement. Now we're making a converse statement. And then let's see if this is true. Let's determine the truth value. If there is no school, then it's Saturday. Is that true? No, because once again, what about Sunday? So that would be false. And our counter example would be Sunday. If there's no school, it doesn't have to be Saturday. It could be Sunday. Or it could be a holiday. It could be a Monday or Tuesday or Wednesday. When there's winter vacation, there's no school. But that's not always Saturday. All right, now let's do the contrapositive. What was the symbol for contrapositive? We're going to negate and switch. So we're going to take if not Q, then not P. Not P. So where's Q? It's over there. There's no school. And what's the negation of no school? There is school. So if there is school, it's always if and then. If there is school, because that's the not version of there's no school, then we need the negation of it is Saturday. So that's going to be then it is not Saturday. Okay, and is this true? If there is school, then it is not Saturday. And that would be true because if there's school, it's not going to be on a Saturday because we don't have school on Saturdays. So this one would be true. And there we go. We have completed our first series of writing inverse, converse, and contrapositive sentences, statements, if you will. Let's do another example to help you guys out even more. Let's do number 2 together. On to number 2. This one's a little more mathy, so maybe it gets a little more complicated, but if you think your way through it, you will be fine. So first, let's label it. So where's the hypothesis? It's always right after the word if, so the product of the two numbers is odd. That's going to be P. And then the conclusion is always right after the word then, so both numbers must be odd. So that's P and Q. So that's going to help us because when we, write our symbols out, then we can just, kind of fill in, substitute for our symbols. So the inverse is formed by negating the hypothesis and conclusion. So it would just be if not P, then not Q. All right, so let's take a look. If the product of two numbers is odd, so we're going to add a not. If the product of two numbers is not odd. But hang on a second, let's think real quick. If two numbers is not odd, if something's not odd, then what is it? It's even, right? So it's a lot clearer to just write even than not odd. So let's write even is even. Then our original statement says both numbers must be odd, and we're adding a not. So once again, then both numbers must be not odd. And once again, if it's not odd, it's just going to be even. So let's just write even. Just like in English class, you're going to write, you can't write in an essay, I ain't not gonna do something. You got to write, I am not going to. You don't write with double negatives, so same thing here. Let's not write with double negatives. Let's just write the actual word, which is even. All right, so now is this true? If the product of two numbers is even, then both numbers must be even. And that's going to be false because any number multiplied by 2 is an even number, right? So even odd numbers can be multiplied by 2, and that would give you an even number, which would make this statement false because look at this. 3 times 2, that equals 6. Is 6 even? Yes, it is. And it's the product of these two numbers. Are both these numbers even? 2 is even, but 3 isn't even. So that's our counter example. This is false. Let's go to number 2, the converse. Remember, to get the converse, we're going to switch the hypothesis and conclusion. So instead of if P then Q, we're going to go if Q then P. All right, so P originally, or let's look at Q first. Q was both numbers must be odd. So if both numbers are odd, then where's P? The product of two numbers is odd. So then we just write it exactly how it is. Then the product of the two numbers is odd. Now, is this true? Well, any odd number is not going to have a factor of 2. You can't divide an odd number by 2, right? That means these numbers, when they multiply together, they still can't be divided by 2, which means that they will be odd. So this one is true. You can kind of think about it for a second, try to find a counterexample, and once you think about it for a while and you're like, man, I can't think of a counterexample, then you pretty much know it's true. All right, and the last one, the contrapositive. Remember, we get this one by negating and switching the hypothesis and conclusion. So first we're going to negate both of them, so it's going to be if not, and we switch, so it's going to be if not Q, then not P. Okay, if it helps you out, remember there's inverse, that's where you take the negative of both. Then there's converse, where you just switch them. And contrapositive is just both inverse and converse at the same time. So you switch them and you take the negation of them. So if not Q, then not P. Okay, so remember, Q was both numbers must be odd. So not Q is if both numbers are even. Remember, look, not Q, we wrote it up here. Remember, then both numbers must be even. So if both numbers are even, then the product of the two numbers is not odd. But remember, if it's not odd, it's even, and we can just write even. So even. That is the negative and the switched. It's the inverse and the converse together, which is the contrapositive. If both numbers are even, then the product of the two numbers is even. And is this true? Yes, it is. If you multiply two even numbers together, then the product will always be even. So our answer is true. Let me just circle these. And there we have it. We have finished number 2. So now you guys try number 3 on your own, and we'll go over the answers in class to see if you got it or not. And that's it for this video. See you in the next one. Peace.